more than 10 minutes, right? I think you can see my shared screen. Can you?
Yes, sir, we can see.
So why I have shared the structured document to give an advice to you, because this is actually a template which the university has provided for the student as a guidance, but don't strictly adhere to it, because it might be appear to the university that same document has been submitted by the students, because there is an issue with the previous batch also, some collusion and the plagiarism problems. So therefore, better to do some initial, put the basic structure that the university has been given, and try to bring it as a uniqueness by yourself, right? Uh, so therefore, I think my advice is that so then we will able to get rid of the problems that are coming related to the collusions and the plagiarisms, right? So that is the best practice, I think, this time, because otherwise the same problem can be arise to your batch also. So therefore, better to use that template as a guidance, but you do some changes to the basic guidance, and you come up with your own structure. So then it will be unique to everybody. And so then if they comment on collusion and plagiarism, so it will be problematic for us, right? So that's what the things firstly I have to share with you. And those who have not attended to this session, please communicate this information to them also, to not to only restricted to the template, better to do some changes according to their requirements, right? That is one point. Other thing is that I can show you one of the example of a student to get an idea that how the assignment should be changed from the the structure that has been initially given by the university. So therefore, better to look into that as well. I think then let me see. So don't get any screenshots and everything, because it will be again problem for you. So therefore, just I'm showing you the thing. So then you can get an idea about the how assignment is should be changed from the initial structure that has been provided by the university, right? So just I'll share it in the screen. So then you can see that one of the students the assignment. So he has initially write about the things that he has learned, and he done some comparisons between the others, and then after that, little by little, he's approaching to his arguments. So then you can see that he has come up with a different way, and he's talking about modern day routings, and so then it's little by little he's comes to his answer, right? So this is the way that he is proceeding. So that to that extent only I can show you, because it is one of the students assignment, so therefore I have no right to share with you. But anyway, I wanted to show you that the structure can be changed accordingly according to your requirement, right? And today as I promised, I like to focus to the online examination, which will be in time to come. So then you will be able to understand what type of questions might come. So I'll show you some questions which I have captured from your online examinations, which are lasted last year. So then you will able to understand what is the type of questions that they give for you. So let me see whether I can share it. Yes. Okay. So this is one of the questions. I'll show you different questions, right? Let's see. So here, one of the question that is more familiar to you, right? This equation shows a calculation for cost in EIGRP. So definitely they will give the equation. And they asking to compare and contrast the default cost calculation for EIGRP and this calculation. So, so then what you have to do is you have to know that what is the basically in default values, how this the particular formula is behaving. So you can see that the answer, the given answer by one of the student, that the default cost calculation only take into account K1 and K3 with the minimum bandwidth and cumulative delay. And he's saying that the K4 and the K5, K2, K4 and K5 are all 0. So as a result of K4 and K5 being 0, there is no values to times by K1, K3, K2 and K3, and so becomes 1 if K5 is not set. So the case K2 is 0, and then so the result is 0 divided by loading minus 256, so which is 0, and then so the 0 is added and ignore the K2 part of the cost calculation, and default calculation is likewise is explained. So that kind of questions, one of the questions can come. And if I go up and see what is here, the question is give a brief description of a distance vector protocol. So then you have to know about something about what is the distance vector protocol and what are the characteristics of it and how it is behave. So all these things briefly you have to tell, right? So it will give, it will contribute 5 marks, right, out of 100. So that kind of questions might come. Let me see. Yes. So here, what are the differentiated services in related to QoS? So one of the question, right? So these are can be got from your reference books, right? In the folder which I have shared. And let me see. So this question I have showed you, and is one of the other questions. The 4G, right? Fog computing. And let's see. This is exactly directly get from your presentations, which was shared by the university under graph theory, right? And let's see the questions. Right, is another question. Give a brief definition of a link state protocol. Right? And here the currently This is one of the name that currently hosts a traditional local IT system. This consists of email, general files, and sensitive data held in database. So they wish to reduce their resilience and reduce costs from the local infrastructure. So what solution would you propose for them? Justify your answer. So that kind of general type questions also coming, right? And also direct question also coming from IP addressing, or also they give questions, right? So this is we had quite a new unit across BC road so that they expand their operation. So what type of wireless antenna should be used and why, right? So that type of questions also can come. Then mostly the routing questions are coming. Which routing protocol would you configure and why? So they will give a scenario and they will ask which routing protocol you propose, and you have to justify the answer. And some other questions. There was a question from IP addressing also. So let me show you that also. This is some of the questions that I captured from the examination held by the university as a sample for the students. So then you will be able to get an understanding what type of questions that come. Right. Let me show.
Hello.
Hello.
Sir, product zoom karanawada. Thank you.
Campaign.
Oh, sir.
මේ තියෙන්නේ මේ අපි discuss කරපු IP addressing වලින් question එක. Match the description with the class, right? So binary address start with 110. ඒ කියන්නේ දැන් first octet එකේ කොහොමද binary pattern එක තියෙන්නේ කියලා අපි මතකයි ඉගෙන ගත්තා. එයා කොහොමද computer එකක් IP address වල classes determine කරන්නේ binary pattern එකෙන් කියලා first class එකේ first octet එකේ. එතකොට කොහොමද 1 to 126 determine වෙන්නේ? එතකොට මේ binary address start with 0 කියලා තියෙනවා. ඊළඟට binary address start with 10 set to 10. එතකොට අනිවාර්යයෙන් මෙයා start කරන්නේ 128 ඊළඟට ඉවර වෙන්නේ 191. ඊළඟට 1 first ඒ කියන්නේ 2 to the power 7 කියන bit එකයි 2 to the power 6 කියන bit එකයි first octet එකේ 1 වලට set කරලා 2 to the power 5 කියන binary bit එක 0 වලට set කරලා තියෙන්නේ class 3 වල first octet එකේ. එතකොට තමයි 192 වලින් මේ address range එක decimal වලින් start වෙන්නේ. එතකොට මේක දිහා බලලා answer එකේ අපිට class එක select කරන්න දෙනවා. එතකොට අපි මේ correct class එක අපි select කරන්න ඕනේ. ඉතින් ඒ වගේ මේකට marks එකකට ලකුණු එක ගානේ marks 3ක් හම්බෙලා තියෙනවා. ඒ වගේ so this kind of very simple questions also coming to the online quiz, right? ඒ අපි IP addressing වල ඉගෙන ගත්ත part එක. ඒ වගේ දැන් බලන්න මේ තියෙන answer එක. The correct answer is binary classes start with 110. Therefore the decimal number can be anywhere from 192 to 223. අපි මේ ටික අපි discuss කළා. ඒ නිසා මේ මොකද ඒක එච්චර ගැළලක් නැහැ. අපි ගොඩක් IP addressing ගැන කතා කරා. මේ තව question එකක්. These addresses are commonly used for local area networks in homes, business, and other organizations. So what we commonly call them? අපි ඒවට කියන්නේ private IP addresses කියලා. answer එක. එතකොට මෙන්න මේ වගේ these type of questions you get, right? This type of question you get. Now you can guess. So my advice is the presentations, especially given by the university, better to refer, because they straight away give the question from the presentations, lecture presentations that they have given. Most of the questions coming. So in addition to that, the reference book that they have recommended, right? So all these things in my folder. So you can refer them when it's closer to the online quiz, right? So better to focus these days to the assignment that is 3,000 words. So then after doing the submission onwards, you will get a 1 week or 2 weeks. So then the online test will be held. So during that period, you can focus to this area and you can go through, right? So that is my advice for the online quiz. And if you get a chance, we'll discuss some theory parts also if you want on online quiz later on. But today onwards, I'm going to explore the presentation that has been given by the university. So then it will helpful for the online quiz which we come that in the future. So then you can utilize that knowledge to do the quiz successfully. So for both you can get marks. You have to get marks, and then they amalgamate or they aggregate these 2 marks and then give the final marks. So therefore you have to do the both the online quiz as well as the assignment. So that is how the evaluation criteria has been given in the module specification, right? So those are the some of the questions that come. I think if I not shared this document, I can share it. I can't remember whether I have shared it in the drive. If it is not available in the drive, so let me know. So then I'll share this document as well to get an idea by yourself, right? That is what about online quiz. And so then we will go to the lectures which was introduced, provided by the university. So then you can go with that also. Let me see. So this is the very first what do you call very first presentation. I think if I do like this, I don't know whether you can see it. Yes, now I think can you see my screen, please? No, I think let me share it. Can you see my screen? Yes. Is it clear for you, the screen?
Yes, sir.
Okay. So actually This is the initial presentation that they have shared with you. Let me see some of the so yeah, the start is here, right? About the WAN technologies. That's why I have done a basic introduction to the networking. So here if we started, so then you will come across a lot of problems because you have to have a initial knowledge about networking. So that's why I started the basic things from basic things, right? So anyway, some questions they have given that which network is typically high bandwidth as a result of removing much of error checking mechanism from DUs, right? So better to look this now. What is packet switching? What is cell switching? What is circuit switching and express switching, right? So they have given some notes with this, right? That which protocol is typically used at layer 3. So layer 3 means the network layer, you know these things. So I'm repeating the things because I have in detail I have discussed these things, not like in university what you call slides. And this is just the explorer, but I have detailedly discussed these protocols also. This is the TCP is a reliable protocol and UDP is a unreliable protocol, and the IP is a layer 3 protocol. TCP is a layer 4 protocol. HTTP is a application layer protocol. So likewise, we have discussed these things and how these TCP and UDP differentiate as what you call connection oriented or reliable protocol, or and also unreliable protocol. So please excuse me. Sometimes my background is a little bit busy today. Some children came from my home, so please excuse because with that background I am doing this. Okay. So the which protocol is typically used at layer 3? So that is you know that it is IP, Internet Protocol, and the TCP is in layer 4, and the HTTP is in layer 7. Likewise, you can should able to understand, right? So then the how this how this OSI model can be utilized to explain that in a protocol stack how this communication is taking place. Also, I have explained. If you can remember the encapsulation, decapsulation, all these things I have explained. So therefore, so how this of each layer of the TCP model or OSI model, how this encapsulation is taking place, you could understand, and also how the different headers are added to this particular PDU, that is protocol data unit. So all these things I have explained, right? And so then use of non-standard protocols, that is if we didn't use standardized protocols, we would have to have many different permutations of links. So at the transport layer, we often use the TCP or UDP. So which protocol does not guarantee the delivery of data. So these things we have discussed. Okay. And the protocols used with the IP, that is internet protocols. So these things we have discussed some of them, that is the BGP, we know the FTP, HTTP, SMTP, right? In my introduction to protocols, I mean, the OSI model and TCP/IP model we have discussed. So you know what is connection oriented and connectionless, and how these three way of handshake taking place, all these things. But this one, I try to explain that anyway. I will repeat it again that there are currently 5 regional internet registries. That is American Registry for Internet Numbers. That is CARIN for North America. These are the organizations which are governing the number signing to networks. Actually, the IP address assigning to the ISPs of each region, and the RIPE networks, that is RIPE NCC, that is the Network Coordination Center for Europe and Middle East and Central Asia. And APNIC is Asia Pacific Network Information Center for Asia and Pacific region. And for Latin American and Caribbean Internet Address Registry for Latin American and the Caribbean region, and African Network Information Center for AFRINIC for Africa. So these are some of the regional internet registry which are governing the entire cyberspace numbering number allocation under the IP addressing IPv4, right? And as well as IPv6. So what is the primary purpose of IR? That is, one is the design of protocols, issuing of public IP addresses, as I said earlier, and the implementation of long-haul point-to-point links and securing the traffic on a wide area networks, right? So they are the people who are governing these areas. And we know that the Internet Assigned Numbers Authority, IANA, that is the delegates internet resource to the regional internet registries. The RIRs follows their regional policies for further sub-delegation of resources to their customers, which include the internet service providers and end users organization. That's what I said. And the collective, the regional internet registries participate in the number resource organization, that is NRO, formed as a lobby to represent their collective interest and undertake joint activities and coordinate the RIR activities globally, right? So that is what initially, and we have discussed the IP addressing, and you can see that I showed you the online, the online quiz. That is a question which was directly got from this slide. That is the class A network is the binary address. It starts with 0. Therefore, the decimal number can be anywhere range from 1 to 126. The same thing they have been taken to the online quiz, which I have showed you very few minutes ago. And you can see the class B networks, the binary address start with 10. So therefore, the decimal number can be anywhere from 128 to 191. So this is talking about the first octet. So, but I have very detailedly discussed this in the initial lectures. And the class C networks, that is binary address, start with 110. So therefore, the decimal number can be anywhere from 192 to 223. So this also we have in detail understood that when we were discussing about the fourth octet and how this first octet has been utilized for binary representation and recognized by the devices, the class full addresses, right? So now what I want to show you is that they are taking most of the questions for the online quiz from these presentations. So then you can understand that, right? So this is about class C and the class E. So I'm not going to elaborate it because normally we are not much used in the field. We are focusing only to the 3 classes, that is class A and class B and class C. So these are some of the private addresses. So there was a question about the private addresses also. If you can remember, that also directly taken from these slides, right? So then this is one of the question that came to the online quiz. That is they asking what is NAT. right? What is NAT? So then you have to give the answer as the network address translation. So you'll see that what is NAT means. NAT is a design to conceive IP addresses and enable networks to use private IP addresses on an internal network. So actually what to do is we configure a NAT server, and we showing the IP addresses of internal IP addresses actually by a public IP address. That is, the public IP address is the IP address which is appearing to the outside, but inside the organization we have make use a different class of IP addresses. So therefore, in another way, it is securing the internal IP addresses exploring to the outside, right? This is one of the main objective of configuring a network address translation server. අපි මේ වගේ එකක් මේ server එකක් අපි config කරන්නේ අපේ internal network එකේ තියෙන IP addresses outside එකට explore වෙන එක වළක්වන්න. Right. So then NAT is designed to conceive. Conceive means that, right? Conservation. ආරක්ෂා කරන්න. IP address and enable the networks to use private IP addresses on internal networks. So these private internal addresses are translated to routable public addresses by this network address translation server. And this is accomplished by internet network devices which are running specialized NAT software which can increase the network privacy by hiding internal IP addresses, right? So that is how it is working. And these are some of the advantages which I have mentioned earlier. It is conceived the legally registered address scheme by allowing the privatization of intranets. So then the organization internal IP address scheme is not explored to the outside. And it also increased the flexibility of connection to the public network, and also the multiple pools we can keep inside the internal network, which can be allow us to manage the network in an efficient way, and some backup pools for reserved IP addresses for different stakeholders, and also the load balancing pools can be implemented to assure the reliable public network connections. So then the consistency of the internal network addressing scheme, that's also another advantage. That means on a network without private IP address and NAT, the change in public addresses requires a renumbering of all the hosts on the existing network. So that is not a very easy thing. And the cost of the renumbering of host can be significant, and it will be costly. And the network address translation allow the existing scheme to remain while the supporting for the new public addressing scheme, because we need to only change the public addresses, and we can keep the private addresses which we are using inside the internal network. So that is another big advantage that we get if we implemented the NAT, right? So these are some of the disadvantages. That means it can cause a loss of functionality with any protocol, or sometimes application that involves sending IP address information inside the IP payload. And sometimes the network address translation increase some delays because it should be mapped with the public and the private, and the switching path delays are introduced because of the translation of each IP addresses within the packet headers. And the first packet will always go through the slow path, which means this first packet is process switch, and the remaining packets will go through the fast switch path, because there are some switching process in routing. Fast process we will discuss, that is first that is process switch, that is go through the fast switch path if a cache entries exist, right? So likewise, these are some of the disadvantages, and also the performance may be a consideration, because the network address translation is currently accomplished by using process switching. So the CPU must look at every packet to decide whether it must be translated. CPU means the router has a CPU, And we know that we have learned that when talking about, discussing about routing. And the CPU must alter the IP headers and then possibly alter the TCP header as well. So, and also the one significant disadvantage when implementing and using NAT is losses of end-to-end IP traceability. And it becomes much more difficult to trace packets that undergo numerous packet address changes over the multiple NAT hops. And also hackers who want to determine the source of a packet will find it difficult to trace or obtain the original source or the destination addresses, right? So this is how the network can be divided into inside network and the outside networks. So the inside interface and outside interface. So this is the IPs that NAT inside and IP in the NAT outside. And this is some of the configuration that used to configure a NAT. So that's also there. So I'll mark the register because got a lot of people join with us. So therefore I take the attendance, right? Okay, so then if I jump to the presentation again, so you can see that the terms that we are using in networking, that is inside local address, the IP address assigned to a low host on the inside network we call the inside local address. The address is usually not an IP address assigned by the Internet Network Information Center or service provider. So this address is likely to be an RFC 1918 private addresses, right? Inside global addresses means a legitimate IP address assigned by the NIC or service provider that represent one or more inside local IP addresses to the outside world. The outside local addresses means that IP addresses of an outside host as it is known to the host on the inside network. Outside global address means the IP addresses assigned to a host on the outside network. The owner of the host assign this address. So therefore, please keep in mind these terms. Sometimes when you comes to the online quiz, sometimes they might put a question related to this slide also. So therefore, better to mark it this slide also. This is one of the slide which will we have to refer when the online exam is closer, right? And these are some of the WAN technologies that the university has been explored. One is called the point-to-point links, right? This dedicated point-to-point links, right? So better to enhance your knowledge about what is a point-to-point link and in which occasions we are using these point-to-point links. And one of the other technologies, the packet switching and the circuit switching. Those things are can be seen elaboratedly in SLT SLT website like ISP websites. I was given advice that to you that better to refer these websites in under the ISPs, especially SLT, Dialog, and Mobitel, and also the Airtel likewise. So then some of the latest technologies, WAN technologies, which are available today for the customers, you can refer, right? So therefore, please do that reference also. And this some of the definition of terms which is given, and that is terminal equipment. Now, we know that if you get a internet connection to our home, now if you think that your home is this one, so we have some devices which is belongs to the ISP. ISP means the internet service provider. So one of the devices which we can recognize, which is owned by the ISP is the modem, that is CSU DSU. So right, CSU DSU means that is we call for the modem, right? the channel service unit and data service unit. Briefly, we call CSU, DSU, which is provided by the ISP. That's why it is say the ISP supply, right? And also there are some two devices that we use, that is the data communication equipment and data terminal equipment, we call it, right? So here that's how the home network and the wide area network will be connected, which is owned by the ISP, right? So therefore we should know about these things. These standards. This is a V35 means a cable that which we use to connect these CSU, DSU devices, equipments, right? So that is what about the data terminal equipment and data circuit terminating equipment. And WAN service providers, that is, you know that some service providers are what do you call the point-to-point or circuit switch connection they have. So these things should be better to understand, and some of the WAN standards better to understand. What is the signal standard and what is the bitrate capacity? So E means the European to denote the European standards, and T means to the USA, and SONET means the synchronous optical networks, right? So if you look at the T, that is T1, that is the USA, right? So E means the European technologies, and the OC one means the SONET, right? SONET technology. These are used for fiber optic cable capacity measuring. This is a metric that they use to measure the capacity of a fiber optic cables bandwidth, right? So these are some of the WAN devices, that is routers we use, switches, the modems, that's the CSU, DSU, and communication servers. And these are some of the LAN WAN links. You can see that multiple buildings are connected together by the routers, right? The routers are the devices which are connecting different networks. So this is some of the extra information that has been given for what you call WAN wide area network encapsulations and HDLC technologies. So please refer to these particular notes, so then you will be able to understand some kind of a knowledge. And please read on these some further notes, right, in Google. So this is a simple diagram to explain circuit switching. You know that circuit means now in your home also there's a current circuit. So if the circuit has been broken in somewhere, the somewhere in the wiring in your home will be not working. So if you want to light a bulb, I mean switch on a bulb, so then when you switch on the bulb, so then it will make a circuit to the supply, and then the bulb will be enlightened, right? So that's how it's happening. So that's why this word has came to the switching also. So the switching is completed when all these switches are establish the connection in between them. So when the connection is completed and make a circuit like this, so then only this communication is happening. So that is why it is called circuit switching. So packet switching is a little bit different because it is using data packets, and it is searching for the best path. And so in different paths, these packets are going by using a mechanism called labeling. So after when it's received to the destination, these labels will be amalgamated. I mean, these packets will be aggregated according to the labels, and they will make the final packet. And so then it will receive by the particular device in the destination end. And so then this switching is called packet switching, right? So you can read more. It is in the slide. I'm simply explaining, right, with the time available. So this is the network layer of frame relay. So you know that in the network layer, we are using packet, IP packets, and when it comes to the data link layer, that is we know that it is a frame, right? So frame is has this kind of a structure. So this is actually the protocol data unit which we are using for local area network level, and this is the protocol data unit we call to communication in the network level. That is actually layer 3 devices, that's routers which we are using to interconnect the different networks. So those devices use this network layer for communication. So therefore they are using packets as the PDU, protocol data. So we have discussed this DSL, ADSL, SDSL, all these technologies we have discussed in the previous slides for in basic to networking. And baseband broadband difference, sometimes a question might put in the online quiz. That is the baseband means what is the difference between the baseband and broadband. So baseband means line technology that uses a single frequency for transmission of data. Broadband means line technology that uses multiple frequencies for transmission of data. So this is simply you can write the answer in this way. And these are some of the types of DSLs, digital subscriber lines. So the X means actually it can be subject to change. Right now, if you can see that the DSL add with A, so that means asymmetric DSL. A symmetric DSL also. Okay, then it's add the S, high bit rate DSL, that is HDSL. ISDN, that is IDSL, we say, right? Like ISDN. And rate adaptive DSL, array DSL, consumer, CDSL. So likewise, there are different types of DSL. So you can prefer some documents to enhance your knowledge. So this is ADSL, how it is behaved, and this is the waveform. And here's some of the DSL typical services, and how the download speed and upload speed is varying. Now you can see that very clearly that asymmetric digital subscriber lines, they have a higher download speed and lower upload speed. So that's why it is asymmetric. But when it comes to the symmetric level, so the both download and upload and upload data transfer speed is very similar to each other. So that's how it is differentiated. So then some of the other areas that online quiz can come, and that is access control list. So which is used to enhance the security of routers like devices. The routers provide capacity to filter traffic, that is the blocking internal traffic with access control list. So now you can understand why we use this access control list, right? So whenever we want to block the network traffic, right? So the access control list is a sequential of list of permit or deny. Now, when you look at the access control list configuration, so these two words you can notice. The one is permit. Permit means you not blocking, you allow some particular traffic. Deny means a particular traffic you are blocking. So these two words definitely come when you are writing a access control list configuration or statement, access control list statement when you are writing, and that apply to address or upper layer protocol. So this can be applied to addresses or upper layer protocols. So there are two types. So this is you should know, because this type of questions I can remember they have given what are the different types of access control list they will ask. So then it's a small answer that you have to write the standard access control list and extended access control list. So the ACLs are a way to control network traffic and can be used as a part of security solution. So that's now you can understand what I have explained, right? So this is one of the slide that you have to mark and keep this one of the area where online quiz that can come to you. So where should the access control list be placed? So actually you can see that this router. So most of the traffics are coming here through this router. So then you can you can control this device because it is connected with the internal network and some of the core level devices. So therefore, sometimes the outside traffic also connected to this. That means the WAN connections are there. So therefore, this is very critical point when you consider one of the organization's network. So if someone is attacked to this and enter to the past this router, so then these all these areas will be vulnerable to attack. So therefore, we have to control the traffics which are coming towards this router. So that's why the ACL should be placed, right? So now you can see that what is really happening when access control list is placed in a device. You can see that this is one of the frame we use to communicate within a LAN, local area network. And also inside that you can find the data packet, because when it's past the data link layer and when it's entered to the network layer, so then it will drop the frame structure and it will interact with the packet structure. So then IP packet header is there, and the segment also inside there. You can see the segment always it is interact with the transport layer. Now you can see how these the encapsulation has been taken place, which we were explained in the OSI model as well as the TCP/IP model, right? So in access control is what we do is actually we are interact with these frames, packets, and the segments. So there we can use the access list statement to test the packet, right? Whether this packet we are allowing to go or deny it to go. So there are sometimes in the access control list we can, in the statement we can say that we look at this packet and whether it should be permitted. So we say it should be permitted, or we suspend this packet. So then we can say we should deny this, right? So what a access control list can be used for? So one of the advantage is that limit the network traffic and increase the network performance. And so there are the access control lists that restrict the video traffic and could greatly reduce the network load and increase the network performance. Now look at very keenly you have to look at this slide because sometimes the university might ask certain question that what can ACLs can be used for. So then you can write these small answers for them in point form. The limit the traffic can increase the network performance, one thing. And the another thing is provide traffic flow control. Access control is provide that opportunity. That means it's restrict the delivery of routing updates. And if the updates are not required because of network condition, so then the bandwidth is preserved. So then the bandwidth can be safe, keeping safe for utilizing for other purposes, and provide a basic level of security for network access. That is also another thing that the ACL we use for. So therefore, it's allowed one host to access a part of the network and prevent another host from accessing the same area. So if you want to put some restriction from segmented network, so then we can put this restriction, and we can avoid the transferring or accessing of these traffics by the users who are not allowed to access, right? And decide which type of traffic are forwarded and or blocked at the router interface. So that's also determined by the that also can be controlled by a access control list statement. And it is permit or deny the access of host to a network segment. And also the access control list can be used to permit or deny a user access file type such as FTP or HTTP. Now, if you want to block internet facility for a user, if you want to block file transfer facility for a user, so that's also possible with the access control list statements, right? So we have been to 1 hour there. So if you like, we can proceed to 3:30, and we can take a break, and we can start from there, right? Anyway, we'll continue until 3:30. I don't know whether you have not taken your lunch or any problems. If a problem like that, I can give early the break. Otherwise, we can continue until 3:30 and give a small break and continue from there. How is your suggestion? Some people getting their lunch lately, no? That's why I asked.
Yes.
Any suggestion? Hello? Yes? No answer?
No, sir, we can continue.
Okay. Thank you. Right. So then no ACLs. That means if ACLs are not configured on the router, the all packets that pass through the router will be permitted to access the entire network. So that is how the ACLs are working, access control list. So this is one of the logic that we can use for it. That is how the access control list works. That means the packets to interface in the access group, it will match the first test. And also there's a match the previous test and the match the last test. So likewise, it is checking, and then it is look at when it's reached to the destination interface, whether it's permit or deny. If it is permit only, that particular interface will be passed. Otherwise, it will deny, and the packet will be discard to the discard, and it will not go further after the implementation of the access control list, right? So this is the types of access control list which I have pointed out to you that the question might ask from this area: standard ACLs and extended ACLs. So how a standard ACL configured. So there are 3 steps we have to follow. One is first you have to deny the traffic, and then after that final permit all the other traffics and configure the interface. So that means deny all the traffic means we know that all the traffics are denied, and no traffic will be allowed. So then after that we can permit according to our requirement, and then configure this interfaces. So that is how the standard ACL configuration is happening, right? So then that is first one, and then we look at to the second presentation. So I'm going to do that also because sometimes it might be benefited for your online quiz. That's why, right? Okay. Right. So see that give me 1 second, right? Right. Now, can you see my screen, please? Hello?
Yes, sir.
Okay, fine. So, thank you. So, we look at the aim of this lecture, right? That is actually to introduce the graph theory, the basic things, right? I can see. Right, and also to detail some popular spanning tree algorithm, and to look at the router discovery algorithm, right? So some of these few small question might come to this area to the online quiz. That's why I cover up these things. Actually, if you look at what is graph theory, that is actually it is a mathematical theory. The graph theory is a study of graphs and which are mathematical structures used to model the pairwise relations between the objects. They're made up of vertices, nodes, and points, which are connected by the edges, arcs, and lines. So when we doing the slides, better to understand these terminologies. What is vertices? What is nodes? What is points? What do you mean by edges? What do you mean by arcs? What do you mean by lines, right? And the graph may be undirected, meaning that there is no distinct between the two vertices associated with each edge. and its edges may be directed from one vertex to another. And the graphs are one of the prime object of study in discrete mathematics, right? So first we try to understand these terminologies, right? The nodes means vertices, another word, right? So hereafter when we talk about vertices, you should understand this picture, right? Node means vertices. So vertices means nodes. What do you mean edges? Edges means a link between two nodes, right? Link between two nodes or link between two vertices called edges, right? So now you know what do you mean by vertices? What do you mean by edges, right? It's one of the these theory has been got from this book that is the Handbook of Graph Theory. That is discrete mathematics and its application. So it is Jonathan N. Gross and J. Yellen are the author, edited this particular book. So it is more complex, right? And actually, most of the network mechanisms are utilized for this graph theory, right? For different protocols functionalities. So more complex, right? Now you can see that if you look at the metro lines in Singapore, UK, USA, like countries, they have railway lines. You know that very easy to travel, right? They have all these maps, not like Sri Lanka. They have there are plenty of underground railway lines. Those rail lines called metro lines, and from 5 minutes to 5 minutes, the trains are available to different locations, and very economical as well as very fastest transport system in the world, right? So actually in Sri Lanka we can implement this very easily because there is no any earthquakes, there is no any natural problems. Because of that, very easily we can implement this type of a structure. But unfortunately, the country is not economically healthy and wealthy. So that is a problem. We can't implement this type of project. And also, if you go for a project like PPP project, that is public-private partnership, so that's also some problem with our people because they against to these projects, and sometimes they not maximally utilize the project for the benefit of the public. Sometimes different corruptions and the transparency issues are there. So because of most of these reasons, still Sri Lanka is Lanka doesn't have this type of a map. But very recently, I have seen that there was a small type of map about this type of which is connecting the Battaramulla and the Colombo city area and Kalani Valley, all these things. But that's also is still dragging 1 or 2 years, right? Anyway, so this is one of the example that they have taken, railway line. Now, sometimes we can say road network also like this we can take as a graph. So this was actually began in year 1736. The great mathematician Leonhard Euler published a paper giving the solution to the following puzzle. What is the puzzle? The town of Kings Weinsberg in Prussia. Prussia means now Kaliningrad in Russia, right? The names are changing.
Excuse me, sir.
Yes, please.
We are not able to see the display. I think it's around 5 minutes. The display is gone.
You can't see the display.
Yeah.
Okay, let me check. Sorry for the inconvenience. Okay. Now is it okay?
Yes, sir, we can see now.
Oh,
Actually, we missed a slide from that graph theory book, handbook.
Here. Slide also you didn't see?
No.
Okay.
So we saw that one like a graph theory, the handbook of graph theory.
Handbook of graph theory. For up to that level you showed, no?
Yes, sir.
We'll start from here. It was enlarged a little. It was begun in 1936 when the great mathematician Leonhard Euler published a paper giving the solution to the following puzzle. So if you look at what is the puzzle is, actually it is the town of Königsberg in Prussia. Prussia means, I think, the new name is different. It is in Russia. That is Kaliningrad, right? Kaliningrad in Russia. I don't know whether I pronounced it correctly. And was built at a point where the two branches of Pregel river came together, right? It was built at a point where the two branches, so branches means Atuganga Dekak, right? The Pregel river came together, right? So it consists of an island. So because of this this branching, it is consists of an island and some land along the river banks, right? So this was the puzzle that he has tried to resolve by this theory. So you can see that these are the trails, paths, and circuits. These were connected by 7 bridges, right? You can see that this is the original. This is the original landscape, and from this it has been extracted. The river, the Pegel river, they have been extracted like this, and they have drawn this picture, and they try to graft it, right? So we'll see that how they have grafted. So the question is this that is it possible for a person to take a walk around the town, that is starting and ending at the same location, and crossing of the 7 bridges exactly once? That means we have seen So he has to start his journey from one point, and he has to come again to the same point. But during this journey, he has to pass all these 7 bridges, right? So that is the puzzle, right? Then how it should be, right? So the in terms of this graph, the question becomes the following: that is it possible to find a route through the graph that start and end at the same vertex? Now you know what is vertex means, vertices, right? And vertices means nodes, and edges means the links, right? The A, B, C, D are the vertex, that is nodes, and transverse is edge exactly once. Edge means the links, right? So equivalently, is it possible to trace this graph and starting and ending at the same point and without ever lifting your pencil from the paper? So this is how it should go, right? That is, it is starting from here without lifting, right? So you can see that like this, right? Like this way. Then like this way, this way, so this way, this way. So anyway, the pointing of these letters, you can see, right? The A, B, the C, right, and D, again A, and here, and then from C, I don't know, that is A, here, 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 yes, say or this say. So it should be like this, right? So you can try, okay? So what is the condition? Is it possible to find a route through the graph that start and end at the same vertex, that means same node, and one of A, B, C, D, and traverse each edge exactly once, right? The equivalently, is it possible to trace this graph starting and ending at the same point and without ever lifting your pencil from the paper? So that's how it should be do, right? You can't lift the pencil. Then only you will be able to find that it is only what you call it is only once that the each of the edges will be utilized into go, right? So the looking for a route is frustrating because you continuously find yourself at a vertex that does not have an unused edge on which to leave, right? So while elsewhere there are unused edges that must be still be traversed. So if you start at the vertex A, for example, so each time you pass through the vertex B, C, or D, so you use up 2 edges because you arrive on one edge and depart on a different edge, a different one, right? So you have to look at what is directed versus undirected. That means the graphs can be directed or undirected. So in this way, you can see that the question is which graph is directed. So that is we look at that is connectedness. That is it is easy to understand that the concept of connectedness on an initiative level. Roughly speaking, a graph is connected if it is possible to travel from any vertex to any other vertex along a sequence of adjacent edges of graph, right? So now you can see this is called connected. This is called disconnected because the for other vertex you can't. That means any other vertex along a sequence of adjacent edges of a graph. So that if it is possible to travel of any vertex, if it is possible to travel any of vertex, so this is possible, no? Any vertex you can travel, but here of course this is disconnected. So therefore you can't say it is connected, right? So these are some of the connected or disconnected ones. This is actually, yes, connected. Right, this is connected. This is disconnected. Right. So we'll see what is this. The graph represented in A is connected. So that is correct. It's connected. And whereas those of B and C are not. B and C are not. Right. And what it says, to understand why C is not connected, we know that in a drawing of a graph, two edges may cross at a point that is not a vertex. Two edges that means two edges may be crossed at a point that is not a vertex. If it is two edges are crossing together, so we can't take it as a node. That's what it says. Vertex means node. Vertices means nodes, no? Right. And so therefore the graph C can be drawn as like this, because you can't take those as a nodes. So therefore you have to draw them as separate. All right. So this one you can't take these points as nodes, right? So then you have to draw it as a separate vertexes. So this is a simple notation. You can see. Simple notation. So here the graph is normally represented using the notation. So this is the notation. Don't confuse it with it. It's a simple mathematical formula, and it is represented by these values. So therefore you can see that the values that has been taken now. If you take 1, 2, so this is this vertex. That means this edge or this link, right? That is 1, 2, and 1, 5. You know this edge, and 2, 3 is this edge, and 2, 5 is this edge. Then 3, 4 is this edge. 4, 5 is this edge, and 4, 6 is this edge, right? So why do we care? That is, we have to have a very brief introduction to graph theory. But why do we care? That is, we care because the network topologies are often represented as graph. Then graph theory. So why graph theory we want? Because we are making or developing network topologies by referring to this graph theory. Algorithm can be designed using graph theory. That's also another advantage of inward networking. That is, in your routing, we have to find the shortest or the best path. So there also we need the graph theory, the algorithm, right? And also the researchers often use graph theory for answers to quite complex problems. So that's also another place where the graph theory we want, right? So we'll continue from there after taking a break, right? 10 or 15 minutes, and we will come back again. So you can get your whatever the break for lunch or tea, whatever it is, and we'll come back again. Shall we?
Okay, sir.
Okay, thank you. So, and also there's another area that the graph theory has been utilized, that is spanning tree. You know that spanning tree is used to avoid the looping of traffic in a network, traffic in a network. So a spanning tree is a subset of graph G, which covers all the vertices with minimum possible number of edges. So as a spanning tree must not have cycles. That is the main objective of configuring a spanning, and nor can it be a disconnected graph, right? So therefore, we the spanning tree always try to disconnect the graph and find out the graph where the disconnectivity is there, right? So every connected and undirected graph G has at least one spanning tree. So the spanning trees are used to computer networks to prevent loops. Now you can understand what the loops means, making circuits. Now, if you look at the spanning tree, that is a walk that is allowed repeated edge and repeated vertex allowed, and the start and ends at the same point and must contain at least one edge, right? The trail, that is repeated edge, no repeated edge, but repeated vertex are allowed, and start and end at same point, but must contain at least one edge is no. And path, that is repeated edge, no, repeated vertex also no, and start and same points also no, and the must contain at least one edge also no. The cross work means they are the repeated edge allowed, the repeated vertex allowed, and started and point at the same point is yes, and it must contain at least one edge also no. Circuit means the repeated edge no, the repeated vertex allowed. You know what is edge and vertex. Vertex means node, and edge means links, right? And starts and ends at same point, yes, and must contain at least one edge is no. If you take circuit means we have seen that circuit means loops, right? Repeated edge no, and repeated vertex allowed, and start and end points at same point is yes, and also the must contain at least one edge, yes. The simple circuit no, and the repeated edge and repeated vertex first and last only, and started and ends at same points yes, and the must contain at least one edge. So in computer networks actually, so what is the best graph theory terminology of the transversal of spanning tree is the question in front of us. So if you look at the number of edges, any two spanning trees for a graph will have the same number of edges. The number of edges means the links, right? For a spanning tree is always one less than the number of vertex. Now look at that logic, right? The number of edges for a spanning tree is, edges means the nodes. Sorry, edges means the links. Trees is always one less than the number of vertex. That means vertex means nodes, right? If you look at find out all the spanning trees for the graph G, that is here you can see, right? There's a loop, right? There's a loop. So this is the, these are the possible spanning trees, right? Here there's no loops. Okay, here also no loops, right? So because this vertex, sorry, this edge has eliminated, and here this edge has eliminated. So therefore there is no loops, right? So now clearly this is a solution, but it is the best. Is it the best solution? That is the question. The answer is yes, because a tree has been created, no circuits. Tree is there, but no circuits are there. So therefore this is the best solution. So this graph was created by simply removing the circuits. This graph is created by simply removing the circuits. Now you can see the circuits, right? There, the circuits are there. But if you look at the solution, so all the circuits have been removed, and the graph, the tree has been remained, right? So now look at this example comparatively. Now you can see. So this is the question, and this is the solution, right? It's the question, and this is also, now you can see. So these loops are removed, right? These loops are removed. Okay, so So far, all our graphs have been unweighted, and the aviation company could introduce miles for each of the link to represent cost metrics. Right now, this is how these airlines are working from different destination. Right, so you can see the vertices as well as the edges, and you can understand the graphs. Right, so the spanning tree, right? So we still need to ensure that the graph is spanning tree. So if we have any circuits, we increase the total mileage, right? So what we want is a spanning tree that is created based on the cost with an attempt to produce a minimum weight spanning tree, right? So if the G is a weighted graph and E is the edge of G, and then the VE denotes the weight of the E and the VG denotes the total weight, right? So the Joseph Kruskal, born January 28, 1920, and died this date. So 82 years old he, the American mathematician and statistician and computer scientist, the best known for Couscous Algorithm, 1956. Right, we'll see what is he said. The edges of a connected weighted graph are examined one by one in order to increase the weight. Right, the edge being examined is added to a data structure, and providing it does not create a circuit. So after n-1 edges having been added, when n is the number of vertices of the graph, right? These edges together with the vertices, you know that nodes, right, of the graph form a minimal spanning tree for a graph. Now let's see how it is happening, right? So it is theory is that n-1 the edges have been added, right? Now look at how this 6 iterations comes, right? Let's see. So this is the initial graph, and we should be able to find out the different the paths, right? Okay. Now look at the AD is the one of the link, or we can edge. We can say this is AD, right? Now look at the next edge, CE, right? It is also 5. The cost is 5. Now what we're going to do is we try to find out what is the shortest distance among the destination, among the nodes, right? So then what is the third one? The cost is 6, that is DF, okay? And look at AB 7, the cost is 7. And BE also 7, right? And FE, so the FE also, FE is 8, right? So is this correct? So that is the question. That is wrong, no? So then the next table entry, right? If you look at that is 9. So why this the earlier one is wrong? Earlier one is wrong because it is making a spanning tree, right? There is a spanning tree if you connect this one, right? So then how it was corrected? So it was corrected. So this edge we have considered. Now it is making a tree. It is not making a loops, right? So that's how it should be. Now this is your turn. So can you do this exercise, and can you convert this into a spanning tree? Shall I give 5 minutes? So you have to understand what are the loops there, and you have to look at what are the loops that you have to eliminate, and you can't eliminate the vertices, but you can eliminate the edges, right? You can eliminate edges, but you have to have all the vertices, right? So by keeping all the vertices without removing the vertices, that means nodes, and removing the unnecessary edges, that is links. So you should be able to find out the best spanning tree for this problem. Can you try? So this definitely a question might come from this graph theory. So that's why I am doing this, right? Will you try? So I have to get the attendance again because some people came just now. So I got one, right? 2 people added now. Yeah. Right? So what is the solution? So look at. Now this is the possible solution, right? Can you see that in red color, right? So these are some of the edges that we can remove. Okay. All right. Okay. So the Couscous algorithm, when Couscous algorithms is used on a graph in which some edges have the same weight as others, so more than one minimum spanning tree can occur as output. Now read it again. When a Couscous algorithm is used on a graph in which some edges have the same weight as others, more than one minimum spanning tree can occur as output, right? So to make the output unique, the edges of the graph can be placed in an array, and edges having the same weight can be added in the order they appear in the array, right? So when connected weighted graph is input to Couscous algorithm, the output is a minimum spanning tree. So that is the beauty of this algorithm, right? So there was another scientist, that is a Czech mathematician, and who worked for many years as a professor and administrator at Charles University, and known for Prim's algorithm in 1930s. So the Prim's algorithm works differently from Couscous algorithm. It builds a minimum spanning tree by expanding outward in connected links from some vertex. So one edge and one vertex are added at each stage. The edge added is the one of the least weight that connect the vertices already in T with those not in T, and that vertex is the endpoint of this edge that is not already in T. So let's look at the Prim's example. Now the same example they have taken. So from A to D is 5, the path. From D to F is 5, sorry 6, and from A to B is 7, from B to E is 7, from E to C is 5, and E to G is 9, right? So this is the one, right? So this is the answer for this one, and so we have to note that the tree obtained is the same as the obtained by the Couscous algorithm, but the edges are added in different order. Edges are added in different order, right? So you can see the earlier one also. Just added in different orders.
Excuse me, sir.
Hello.
Excuse me, sir.
Yes, please.
So it should be the shortest path, right? To the next
Exactly.
node.
Exactly.
Between the nodes, we should go through the shortest path.
Exactly. Yes. Exactly.
Oh. Thank you.
Because now when you consider about the networking and refer to the routing,
Yeah.
actually, yeah, you are try to find out the best path, isn't it? So therefore,
Yeah.
the cost
That
value
like
should be
autonomous,
least cost.
it will be fine. It's in the autonomous, it will be find the automatically like the shortest path, right?
Shortest
Sir?
path. Yes,
That-
correct. Yes, correct.
Thank you, sir.
And so then, sorry for the. Excuse me. Hello. Okay, sorry for the interruption. Right. So then we have to note that the tree obtained is the same as the that obtained by the Couscous algorithm, but the edges are added in a different order, right? So the Couscous algorithm, in order to ensure unique output, the edges of the graph could be placed in an array, and those with the same weight could be added in the order they appear in the array, right? So this is these are the two algorithms, and in practical perspective, you can see that in a network designing the topology, we can use the same theory to minimize the looping and minimize the making of circuits, and we can enhance the network traffic movement in the within the network and the outside the network, right? So therefore, it's a very useful theory. Useful theories for network implementations in practical perspective. So this is one of the algorithm you can see that is called Distra's algorithm, where the Ospf utilizing, and this is one of the map of network map which they utilize in the internet to find out the shortest path, right? So you can see that the Distra's algorithm find the shortest path from given source nodes to all other nodes. It's developed path in order of increasing the path length, and algorithm runs in stages. That means each time the adding node with the next shortest path. So because of that, it will not eliminate any short path in the path where we are to destination nodes. The algorithm terminates when all the nodes have been added to the T, right? So if you look at the algorithm's method, the first step one is the initiation, and then the step two is the get the next node, that is find in the neighbor node not in T with the least cost path forms and incorporate into T. Then also it incorporate the edge that is incident on that node and a node in T that contribute to the path. That means if one of the connection has been loosed, so then he has to find out alternative path. That means a particular link has been failed, and so he has to find out a new link to the destination, and also if there's multiple links to be considered, then he has to be considered the least cost link to the destination. So otherwise the best path will be vary, right? And it will not be the correct path, right? So this is how the Dijkstra's algorithms works. You can see that how it is determined in the the T or the best path to the destination, right? Right. So this is a example of least cost routing algorithm, and how this the iteration is using, and look at the path distance this way. So likewise, that is how the distrust algorithm find out the shortest path. You can see, right? Here the A, 2AB, AB if you take it's 2. So if you take AC, look at Are you okay? Can you hear me?
Yeah, we can.
Hello?
Yeah, we can hear.
Okay, right. So he was talking about this Vistras algorithm example. Now, if you look at the A, Ola infinity, this mark is infinity, right? අනන්තය කියලා කියන්නේ අපි. Right. ඊට පස්සේ දැන් අපි බලමු next we look at how this edge is working, right? It is bidirectional, right? So A to B, the cost is 2, right? So A to C, the cost is 5. Is correct, no? 2 plus 3, 5. Then look at the D. If you connect with the D, right? The cost, right? A to B 2. The ADC is what do you call 4? That is 1, 3 equal 4, right? So AD. If you look at AD. So AD is 1, right? Yeah, AD is 1, right? That direction. So the B, now look at B, the cost is 2. So the cost 2 come, that is ADE, ADE, right? ADE, sorry, ADE is 2, the cost is 2, 1, 1, 2, right? Then E, the cost is 2, that is ADEC, right? ADEC, the cost is 3. ADEF, ADEF, the cost is 4, right? Correct. The C, the C, right? The ADE, ADE, its cost is ADE is C, the cost is 3, right? AD, if you take, cost is 1. CE, if you consider, the ADE is 2, ADE is 2, right? And if you look at ADEF, ADEF is equal to 4, right? So the cost is 4, right? So likewise, you can see that the traveling salesman problem, right? Traveling salesman problem. Now, how he is traveled in a geographical area. You can take like this graph. Right? So it's very hard, no? Very harder to find right? And the other network problems and algorithms, right? The filtering, not quite so much graph theory, right? The compression, encryptions, right? So you can understand that it is actually a the graph theory, how it is utilized in networking. And also a simple question might come like this from algorithm for your online quiz. So that's it. That to that level that is enough. But if you are interested, you can see that how this network algorithms have been derived from with respect to the graph theory. So that is you can see, and a lot of researchers researching in this area to find out new algorithms for networking. So there you have to study these old algorithms and look at their weaknesses, their strength, and then you can come up with a new algorithm. Now, for example, if you take EIGRP, it has a DUAL algorithm, right? Now, for distrust is for OSPF. So likewise, there are algorithms are there which we can utilize for different networking routing purposes, right? So I'll end up that, and I'll jump to the next presentation because I want to cover up all these things for the betterment of your online quiz. So let's see whether you can see this my presentation. Right, the routing, right? So let me see. Okay. Now if you look at the if you look at the slides, I believe you can see my slides, right? So we have introduced some graph theory, very basic details, right? And we have discussed about distrust algorithms, and now our aim is to discuss about the routing, right? So routing in packet switching networks, right? The packet switch networks route packets from source to destination. So that's what you have to understand. Then packets could go along a dedicated route, right? So that dedicated route is the route that we are going to find out as the best path, right, in routing. And what techniques are used for packet traversing a set path, right? That means one of the techniques that the routers use is circuit switching, virtual circuit in packet switch networks, and alternatively the route could be decided as a packet traverse. What techniques is known as datagram. And also what isn't clear is how the routing decisions are made, right? So therefore we have to look at it, right? So routing packets switching networks. So we need to establish a route across network between in nodes. So when determining a route, we should consider one is the correctness, the one is the simplicity, other one is the robustness, the accuracy, stability, fairness. Fairness means if there's many options, so what is the best option? And optimality, that means how we can get the maximum benefit by the selection. And the efficiency, right? Efficiency means the number of overheads, right? So that is how this one. So these are some of the elements of routing techniques. One is the performance criteria, that is the number of hosts and cost, delay, throughput. Now you can see that performance. One of the performance criteria in routing is a throughput. So you can get an idea for your assignment question which you are trying these days. So there you can see that some of the algorithms, they are only considering for the cost, the delay, the bandwidth, and the reliability, all these things, right? The load, right? But as a routing techniques, as a performance criteria, the network throughput also another criteria that we can consider. And the decision time, that means the packet by packet and the session by session, that is the virtual circuit. Packet per packet means the data plan. And decision place, that is each node, how it is distributed, and the central node, how it is centralized, and originated node, that how the source node, all these things are impact to the decision place. And also network information source, that means the local adjacent nodes, nodes along the route, and also the all the nodes. And also the network information update time, that is how frequently the information has been updated among the routers. For example, is it a continuous update? Is it a periodic? Or is it a major load change? Or is it a topology change? That means, for example, for a topology change is the link state routing protocols, right? So if you look at the performance criteria now used for selection of route, right? This performance criteria is used to select the route, right? The simplest is to choose the minimum hop. That means the minimum number of hops which is placed along with the source nodes to destination node. And also the alternatively based on the least cost routing. That is because the least cost is more flexible. It is more common than a minimum hop, right? And the question is which well-known routing algorithm uses hop count to determine the shortest path. That is the RIP, right? If somebody asks what is the routing protocol which is using as the algorithm the host count, hop count, that is routing information protocol as routing protocol. And the example for a network configuration, that is so the hop count may not be the best performance criteria for determining the route. So which routing protocol use cost as a metric? So that is the one of the question, right? So decision time and place, right? So that is a packet or virtual circuit basis, or sometimes fixed or dynamically changed. And also the place means the distributed, that is made by each node for more complex but more robust, right? And the centralized means the made by a designated node, and source means the made by a source station. So now when there's a packet packets are moving, so this time and place is very important in decision. In network information source and update timing, the routing decision usually based on the knowledge of network traffic load and the link cost. That means the distributed routing, that using local knowledge, information from adjacent nodes, and information from all nodes on the potential road. And also the central routing that collect information from all nodes, right? So issue of update timing, that is depend on the routing strategy, and also it's fixed and never update. And also the adaptive means it's regular updates, right? So routing strategies and fixed routing use a single permanent route for each source to destination pair of nodes. So determined using a least cost algorithm. And the route is fixed means until a change in the network topology, it is fixed. For example, the link state routing protocol. And based on the expected traffic or capacity sometimes. So the advantage is the simplicity, and disadvantage is the lack of flexibility. That means it does not react to the network failure or congestions. So using Cisco terminology, what is a fixed route? What is static route? Those questions can be asked, right? So this is one of the examples for central routing. And the routing strategies, one is the flooding. That means the packet sent by node to every neighbor is called flooding. So eventually the multiple copies arrived at the destination and no network information required. So each packet is uniquely numbered, so duplicates can be discarded, and need to limit the incessant retransmission of packets. So that is the disadvantage of this strategy. And the nodes can be remember the identity of packets and retransmitted, and can include the hop count in packets. Flooding is this the hop count 3, the node 1 searching for the node 6. So if we can't find out the proper path, so then the flooding can be happen. So properties of flooding, it means all possible routers are tried. That means highly robust and can be used to send emergency messages. At least one packet will have taken minimum hop count, can be used to set up a virtual circuit. The nodes directly or indirectly connected to the source are visited. That means all nodes are visited. That means useful to distribute information. That means to send information to all nodes. This is good. Disadvantages is because of this, the high traffic load generated and security concerns also there. Then the random routing, that is it's a simplicity of flooding with much less traffic load. The node selects one outgoing path for retransmission of incoming packets. Selection can be random or round robin. That is, refinement is to select outgoing path based on the probability calculation. No network information needed, and random route is typically neither least cost nor minimum hop. So adaptive routing means used by almost all packet switching networks. The routing decision change as the condition on the network change due to failure or congestion, and it requires information about the network. The disadvantages is the decision is more complex, and at the trade-off between the quality of the network information and the overhead, and the reacting too quickly can cause oscillations, and reacting too slowly means the information may be irrelevant. So the adaptive routing advantages, that is, it is improve the performance and aid in congestion control. So these benefits depend on the soundness of the design and the nature of the load of the traffic. So these are some of the classification of adaptive routing strategies. That is, it's convenient way to classify is on basis of the information source. That means local, adjacent, and all nodes. This isolated adaptive routing. Example, the packet arrives at a node 4, and from node 1, which link will be used for the forward the packet. So that that decision has to be made. So the node 4 bias table for destination 6. So that is according to the bias is selected. The ARPANET routing strategy is the first generation. It's a distance vector routing that is in 1969. So the distributed adaptive using estimated delay, that is the queue length used as the estimated of the delay. So the version of Bellman-Ford algorithm. So you can look at when you are doing the assignment, you can find out what the Bellman-Ford algorithm you do. So you can get an idea about that also, and you can think about the other routing algorithms respect to the Bellman-Ford. And node exchange delay vector with neighbors, and update routing table based on incoming information. And does not consider the line speed, just queue the length and response load into the congestion. So these are some of the ARPANET routing strategies in first generation. So better to refer to the Bellman-Ford algorithm. It will be useful for you to get an idea about the assignments, a new routing protocol, right? The original data structure is ARPANET. So this is one of the example for this. So here it is, the destination is there, the delay is there, the next node is there. So the node first routing table before update. So then the delay vector sent to the node 1 from neighbor nodes, and then after that the destination the nodes one routing table after update and link cost used in the update. So the estimated link delay, that is the queue length of the link, that means estimated link delay. When building a new routing table, the node will favor outgoing links with shorter queues. The problem is that the queue length vary rapidly with the time. So the distributed perception of that shortest route could change while less packet is in route. That means it could lead to the trashing. That means a packet that continues to seek out areas of low congestion rather than heading for destination. So the second generation is the link state routing. Now you can see that the first generation is distance vector routing, and the second generation is the link state routing. It recomputes the average delay every 10 seconds, and any changes are flooded to all other nodes. So then recompute the routing using distrust algorithm. Good under light and medium loads, and under heavy loads, little correlation between the reported delay and those experienced. The packet switching oscillation is the most traffic on link A. Link delay at significant, that recompute the links of every 10 seconds, and all nodes update their routing tables. And now the link B, the preferred routing choice, that means now the link delay becomes significant. So it recomputes the links after every 10 seconds, and all the nodes update their routing tables. Excuse me for 1 minute, 5 minutes, right? Sorry for the inconvenience, right? Some visitors came, so let's say goodbye, right? So then we were discussing about packet switching oscillations. The most traffic on, now if you look at the link A, right? It's a link delay significance. The recompute the links 10 seconds, and all the nodes update their routing tables, right? Now the link B is preferred routing choice sometimes, right? After the updates, and it recomputes 10 seconds again, and all nodes update their routing tables, right? Now the link A is the preferred routing choice. Now the link delay becomes significant. So likewise, this is called the oscillation. Oscillation means from one link to the another link, it's moving, right? Changing. Okay, oscillation means that. So therefore, the packets are moved sometimes from link A, sometimes link B, right? So that's how it is oscillation. So according to the recomputing the links, it's update all the links and their routing tables. Then after that, it determine the best path. So then sometimes the best path may be A, sometimes the best path may be B. So likewise, it will be very oscillate. In third generation, it is in 1987. That is the link cost calculation change. That means that the damp routing oscillation and reduce routing overhead. So they measure the average delay over 10 seconds and transform it into link utilization estimate. Measure the average delay over the last 10 seconds, and transform it link utilization. ඒ කියන්නේ පහුගිය තප්පර 10 ඇතුළත තිබුණ delay එක කොහොමද කියලා measure කරනවා. ඒ වගේම මේ link එකේ utilization එක transfer කරනවා, estimate කරනවා. So normalize this based on current value and the previous result. So therefore, it set the link cost as the function of average utilization, right? So the link has been utilized more. That's how it is get an average. So how these links has been utilized, right? How this link has been selected as a best path. So in other way, right? Internet routing protocol. So the routers are responsible for receiving and forwarding packets through the interconnected set of networks. Now makes routing decision based on the knowledge of the topology and the traffic or the delay condition of the internet, right? So the routers exchange routing information using special routing protocol. And the two concepts in considering the routing function is that is routing information and routing algorithm. Now, so far the things that we have discussed about routing, we can come to this determination. That is, some of the routing protocols are using routing information about the topology and delays of the internet. Some are using routing algorithm. So that's why we say that the two concepts in considering the routing function. So the routing algorithms, when you look at the routing algorithm used to make a routing decision for a particular datagram based on the current routing information, right? So autonomous systems comes that is actually when a network is under a single administration domain, right? So it's exhibit the following characteristic. If you take autonomous system, it's a set of routers and networks managed by a single organization. So that's why I called it as under the single administration. And its consists of a group of routers exchanging information via a common routing protocol. And except in times of failure is connected. That means it's connected, and also there is a path between any pair of nodes. So except any failure, so every nodes are connected together, right? And if you look at this slide, we know that we have discussed these things also. What is interior routing protocol? That is a shared routing protocol which passes routing information between routers within autonomous system, not a in between autonomous system. Inside the autonomous system, we can find only interior routing protocols and custom tailored to specific application and requirements. So exterior and interior routing protocols. Now you can see that in this picture very clearly that these are two autonomous systems, right? This is one autonomous system and this is another autonomous system. So you can see that, right? This is one autonomous system. This is another autonomous. So now you can see that some of the sub networks which is connected to these networks, right? So what if you take this autonomous system? It is it is belongs to one organization, and this autonomous system if you take, it is belongs to another organization. And if you look at the interior routing protocol, so these are interior routing protocols, you can see, and these are exterior routing protocols, right? That is between R1 and R5, you can see, right? So routing algorithms in different in autonomous system may differ, right? The routers in one autonomous system need minimal level of information about concerning networks outside the system, because most of the information they are needed internal, right? So if you take exterior router protocols, that is protocol used to pass routing information between routers in different autonomous systems. That is obvious, right? So we'll need to pass less information than interior routing protocol, because the frequency is very less. The routing that is happening inside the autonomous system than in between autonomous system. That's why. And if a datagram is to be transferred from host in one autonomous system to host in another autonomous system, a router in the first system need only determine the target autonomous system. That means to which autonomous system we have to send these packets. and device a router to get it into that target system. That means they decide which router will be do this task. And once the datagram enters the target autonomous system, the router within that system can cooperate to deliver the datagram. So the exterior routing protocols is not concerned with and does not know about the detail of the route. So example, a border gateway protocol and the open shortest path if you take. So the open shortest path is the interior gateway routing protocol. The BGP is the exterior gateway routing protocol in between two autonomous systems. So the approach to routing, that is the internet routing protocols employ one of the three approach to gather and using routing information. One is distance vector routing, one is path vector routing, and other one is the linked state routing. Distance vector routing, it requires that each node exchange information with its neighboring nodes. So the two nodes are said to be neighbors if they are both directly connected to the same network. If they are directly connected to the same network, so they consider as neighbors, right? And used in first generation routing algorithm for ARPANET. So each node now you know what are the different generation of routing algorithms, because we have discussed in the early slides. And each node maintain a vector of link. Now you know what is vector. Vector means the node, and you know edges means links. Cost for each directly attached network, and distance and next hop vector for each destination. So the routing protocols uses this approach. Routing information protocol use this approach, that means the hop count. The link state routings, they are designed to overcome the drawback of distance vector routing. When a router is initialized, it determines the link cost on each of its network interfaces. That means it's map the entire network. The router then advertises this set of links cost to all the other routers in the internet topology, not just neighbor routers. That means everybody will be acknowledged about themselves and their network. From then on, the routers monitors is link cost. Link cost means whether their links are down or up. Whenever there's a significant change, the router again advertises its set of link cost to all the other routers in the configuration. So the Ospf protocol is an example that the second generation routing algorithm for ARPANET also uses this approach. That means Ospf is a link state routing protocol. Path vector routing is it's an alternative to dispense with routing metrics and simply provide information about which network can be reached by a given router and the autonomous systems visited in order to reach the destination network by this route. So differ from distance vector algorithm in two respects. So this type of a question can come. So therefore better to mark this slide for the future in online questions. Differs from distance vector algorithm in two respects. How the path vector routing algorithm differs from the distance vector algorithm, right? So these two respects can be written. The path vector approach does not include the distance or cost estimate, and each block of routing information lists all of the autonomous system visited in order to reach the destination network by this route. Right? So those are the two respects which are differ from the distance vector algorithm. So this might be one of the question in online quiz. And the border gateway protocol, that is BGP, was developed for use in conjunction with internet that employ the TCP/IP suite. So has become the preferred exterior router protocol for the internet, and designed to allow the routers in different autonomous systems to cooperate in the exchange of routing information. The protocols operate in terms of messages which are sent over the TCP connection. TCP is a very reliable communication, right? The current version is known as the BGP4. So if you want more details, you can refer the RFC document 4271 and the neighbor acquisition, neighbor reachability and network reachability. Okay, they use. So it's a BGP for messages. One is open, that is used to open a neighbor relationship with another router. Update messages used to transmit the information about the single route or the list of multiple routes. And keep alive is used to acknowledge an open message and periodically confirm the neighbor relationship. Notification is used to send when an error condition is detected. So this is how the neighbor acquisition occurs when two neighbors routers in different autonomous systems agree to exchange route information regularly. The two routers send open messages to each other after a TCP connection is established. So if each router accepts the request, it returns a keep alive message in response. So then the protocol does not address the issue of how one router knows the addresses or even the existence of another router, and nor how it decides that it needs to be exchange route information with that particular route. So this is how these border gateway protocol messages formats, right? You can see that open message format, update message format, keep alive message format, and the notification format. So this is open message format. What do you think about the purpose of the marker field? That is, marker field is used for authentication between two routers, and a unique ID so that all the subsequent packet can be marked with the ID, and also used to categorize the packet with the different priorities and used to identify the additional routers within the autonomous system. So length is just the length of the messaging octet. What is the purpose of the type field? That is to specify the type of message. That is whether it is a keep alive or whether it is open, likewise, and specify the type of data, that is voice, video, or data. Specify the priority, and it used for priority is used for quality of service, and that means whether we have to give the priority to the voice, the video, or data, and specify type of BGP protocol in use. So the protocol that is RFC 2328 is the open shortest path protocol, OSPF. So if you want more details to study, the best document is this request for comments 2328. Used as an interior routing protocol in TCP networks. It's compute a route through the internet that incurs the least cost based on the user configurable metric of the cost. So is able to equalize the load over the multiple equal cost path. So this is one of the sample autonomous system, and can see this discrete directed graph autonomous system figure, how these paths are placed among these nodes, and you can see the destination nodes and how the next hop are there and how the distance are allocated, right? So that is for your information, right? So that is what in this routing for the time being, and now next day we will go through the routing slides also, which are provided by the university. So then if there is any questions which are directly come from these slides, that's also benefited for you. So I'll finish it off these slides next time because I want to discuss some three slides are there. I mean, three presentations are there. That is about EIGRP again, the OSPF in detail, and BGP in details. So then it will be benefited for you if any question come from these slides, right? And also some few slides are about wireless, right? So tomorrow we'll continue. So is there any problem with the time that we have allocated for tomorrow? Any problems with the time that we have allocated for tomorrow? No.
No, sir.
Okay. So then we'll meet in the morning, no? 8:30.
Yeah.
Okay. We'll meet again in the morning, right? And we'll continue from here. Thank you very much for being with me. All right.
Okay, thank you.
Okay.
Thank you, sir.